Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this particular video, we are starting our very new algorithm in machine learning, and that is about KNN, K nearest neighbor, right? Again, it's a part of a supervised machine learning algorithm, means whatever data we are dealing with in this hands-on implementation, it will be a label data, means a target column is available with us. And basically, it is used to solve both the type of problems, that is regression as well as classification. So if let's say I want to do the prediction of diabetes, whether the patient is diabetic or not, means binary classification, then also I can go for Canon. And if let's say I want to predict that whether what is the house price, we have done that, right? As a hands-on implementation of linear regression. So if that kind of data is also available to us, then also we can apply the KNN algorithm in order to, get the predictions done. So that's the beauty about this algorithm. So without wasting any time, let's get started and let's deep dive into how this KNN algorithm works in terms of mathematical intuition, followed by the hands-on implementation for the same. So let's get started. So now let's try to talk about that how internally this KNN algorithm works and how it is basically helps us to give the prediction even though we are dealing with a regression problem, or as I told you, we are dealing with a classification problem. So let's first of all take an example of a classification problem. I think in my previous algorithms part also, we have taken one hands-on implementation on predictive analysis on diabetic data. Do you remember that? That kind of data set, right? Where we will be having, I believe, 8 features. The last column was the outcome one, where the final result is either 0 and 1, right? I hope you all remember that. So what I'm trying to do here is I'm trying to take the similar example because we all are aware about that, data set, and with the help of which we will be able to understand that how this internal working of K will be there. So what will happen usually is that, let's say we are dealing with the classification task, and we will be having a set of data points available with us, right? The final task is, let's say, to do the prediction that whether a patient is diabetic or not. For now, I am taking only 2 features because obviously I can demonstrate you in a clear manner 2D data. I can't, make 3D, 4D, 5D, 7D, 8D. When I'm saying 8D, 7D, it means number of features are that many. So as of now, let's say we are assuming that we will be having only 2 features, which are basically responsible for the prediction that, whether the patient is diabetic or not. So X and Y axis are there. That's the only 2-dimensional data that we have. Now, what usually happens is that, let's say you will be having one class which belongs to this particular data points. Okay? So this is where you will be having a class which belongs to one data point. Then you will be having another class which belongs to this particular category, right? Let's assume this is the another category of classes, data points that we have. Now, what usually happens is, let's say some new data point came into picture. This is the new data point which is there. Now, this new data point doesn't understand that whether it belongs to this particular class, which belongs to maybe 0 category, or this particular class which belongs to, let's say, 1 category. Okay. So let's assume that all the points which are in a yellow color are belonging to the diabetic patients, and all the points which belongs to green data points belongs to 0 class, means they are not diabetic patients. Now, when new patient record came into picture having the similar features, and when we try to allocate a space of X and Y in that particular new feature, new data point, new test data, now this new data point is not aware that, whether it is 0 or 1. So we need to do a classification task here. So when I'm saying K value as, let's say, 3, K as 3, it means that this new data point will try to focus on 3 nearest neighbors. So what will happen is it will try to find out the distance of this new data point that we have. This is the new data point that we have. And there are numerous points we have in this available data, right? So this new data point will try to find the distance, and it will take the 3 nearest distances. When I'm saying 3, why is that so? Because the value of K, we are saying it as 3. So it will try to fetch maybe the nearest three. Maybe I'm assuming that this is the first point, this is the second point which is nearest, and let's say this is the third point which is nearest. Okay, I'm just giving a assumption that these three are the nearest points comparing to all the other data points that we have. This new data point is very near to the one green one and two yellow one. Now what will happen is internally it will try to find the probability. Now what is the probability of a data point which is a new data point that we have, dp I'm mentioning, belonging to class 1, right? Given belonging to class 1, it is nothing but is equals to 2 by 3, can I say? Because in total we are looking for three nearest data points, and out of those three data points I can clearly see two of them are nearest to the yellow one, which is belonging to the class 1, as I mentioned. Just make sure it's all these things are assumptions. As of now, I'm not going into perfection side. I'm just giving you a hypothetical understanding of how this KNN algorithm works. So just make sure you will also understand in that sense how exact calculation will be done. What are the metrics that we have in terms of distances, which is basically helping me out in order to check it out that what are the three nearest points that we have. Everything we will discuss step by step in every session. As of now, you can say maybe Euclidean distance they're taking up, which is basically helping us to give us a distance metric. And if you don't know Euclidean distance, then also you can say that there is some mathematical metric we have. In the upcoming video, I'll discuss the metrics in the mathematical detail. So don't worry for that aspect also. But as of now, you can understand that we have some metric with the help of which we will be able to have an idea that this new data point is having how much distance from other data points. And the top three minima, we will be able to clearly fetch it up, and we will be able to get an idea that these are the three which I'm talking about, right? This is the first one, this is the second one, this is the third one. Now, probability of new data point belonging to class 1 is 2 by 3. Why is that so? Because two data points are there which belongs to class 1. Nearest points, I am saying. Similarly, if I'll say, what is the probability of a new data point belonging to, I would say, class 0, that is nothing but is equals to 1 by 3. Why is that so? The simple reason is that in this particular scenario, I have only single point which belongs to class 0. I have only single point, which is the nearest point which belongs to class 0. So what will happen internally is now it will try to compare both of these probabilities. And whichever is having a highest probability, it will try to declare that this new data point also belongs to, class 1, because it is having a highest probability as comparable to class 0. So this is the final, I would say, prediction which my KNN algorithm will say. I hope it makes sense. So everything is based on the nearest neighbors, and that's why researchers have given this name as KNN. K means how many number of nearest points we are looking into, and nearest neighbors means we are looking for the close points, right? Not the farthest one. So that's why it's the nearest neighbors. By the way, this algorithm is specifically used in a lot of other algorithms also. For example, we have a technique of SMOT where we try to generate a synthetic data points in the oversampling technique. There also this same KNN algorithm is working on to generate a new samples. So what I'm trying to convey here is please try to understand this algorithm also in a very great detail. Okay. Now, this is specifically I have talked about for the classification case. But if you remember in the intro itself, I told you that this algorithm is used or designed for both the tasks. When I'm saying classification, diabetic example is of classification, whether we are trying to predict the value as either 0 or 1, right? But you can ask me a question that, Priya, what will happen if, let's say, I am trying to go for a regression scenario, right? What is the thing which will happen internally in that case? Here, to okay, you are saying that my model will be able to determine the probability, and whichsoever is having a highest probability, that will be the number which is trying to convey to us as an algorithmically. But one question in classification also you can ask from me that, Priya, what will happen if we have equal probability? In that case, it will take a random data point and will give you the answer. But in case of regression, what will happen? Let's say the same thing will go. Maybe the problem I'll change it to a house price prediction. Okay. Now we are not having the 0 and 1 classes, but I'm looking for the house price prediction. Let's say you are living in a Bangalore in a society of Whitefield, and let's say you are trying to purchase a flat after 5 years, and now you have data available with you, that what is the locality, is there any mall available nearby, any hypermarket is there, right? How much is the size of the flat, how many number of bathrooms are there, how many number of balconies are there, in which floor the flat is located. So with the help of all these factors, we have numerous data points. All these are the features again. Now with the help of which I want to determine that, what is the price of the house, let's say after 5 years, based on the historical data, and considering the inflation also, everything we will try to consider, and with the help of which we will say that, okay, this much crores are required in order to purchase a flat in Whitefield. So what I'm trying to convey here, it's a problem of regression. Now what will happen is, if let's say I want to apply a K-NN algorithm, then will that work? That's the another question. So what will happen is, again, K belongs to same ideology, that K is, let's say, 3. So it will try to find the 3 nearest points. So it means that we do have 3 points data available, that what is the price of the house. Let's say this data point is having price of 1 CR. This data point is having a price of 2 CR. This data point is having a price of, let's say, 3 CR, right? So what my regression case will do, in that case, it will try to find the average of all the 3 data points, which is 1 CR plus 2 CR plus 3 CR, right? Plus 3 CR divided by 3. I hope you all know how basically we can evaluate average, or which we call as a mean in our mathematical terms as well. So it will try to find out the average of all these numbers. So 3, 4, 5, 6, it means that the average price of that particular home, that particular house, that particular flat, which you're looking into, depending upon these 3 nearest neighbors, will be equivalent to 2 CR. So that is how basically regression algorithm will work. So in classification, the major concept in maths is probability. It will try to find out which particular class is having a highest probability. In regression, it will try to find out the nearest neighbors and will take the average out of that and will give us a final number. So this is how the final intuition behind K-NN looks like. So now I hope that you will be able to understand the intuition behind this K-NN algorithm, how it works, what is the literal meaning of this K, what is the meaning of this nearest neighbors, and how with the help of the probability, it will be able to tell us that, in which particular category or class it belongs to, or in terms of regression, how basically it will try to find the average of the, numbers with respect to the K value to give us the final prediction. With this, let's try to end this particular session. And in the upcoming session, we will try to deep dive into the same process, where we will talk about that, we have seen that with the help of the distance part only, it will be able to tell us that, okay, these are the 3 nearest or 4 nearest or 7 nearest numbers or data points that we have. So what are the different types of distance metrics we have? How basically, if let's say we will be having any categorical features, in that scenario, how our model will be able to determine that distance value. Everything we will try to understand in the upcoming part of the session. So stay tuned, and I'll see you all in the upcoming session.